Okay. All right. Hello, everyone. This is the injection molding demonstration session. Well, unfortunately, this is the only way we can do it. So hopefully you can see all the detail here with all the equipment demo we're going to do. Right. Let's start with injection molding. The concept of injection molding is an efficient and rapid way to manufacture a lot of bits and pieces, and mainly dealing with thermoplastic polymers. Now, when we're talking about thermoplastic, let's have a look at the material here. These are the material we generally use. Today, the material we're going to use is polypropylene. This is how it looks like. As a virgin material, it's like a beads or granules. This is basically what you get from the manufacturer. Now, with our equipment, we can also do different types of thermoplastic, like these two bags you're looking at. These two are actually recycled material. So if you have things like bits and pieces of, for example, suitcases, plastic containers, long as we know they are the same material, we can break them up into bits and pieces like fragments and feed these into injection molding machine, and they can be molded as well. Now, if you take it one step further, you can also make the virgin material with a bit of color. So you can introduce pigments or dyes, and a typical example will be these. Now, these are apparently, you can use this to make stuff like Lego or different kids' toys or anything more colorful, right? So these are the material we're mainly dealing with today. Now, if you look at here, there are a few samples I'm going to show you. Typical things, like if you go a little bit back. Now, injection molding can make a lot of big or small items. Now, typically, this is a piece of wheel hub cover or a cap. Now, this thing can be made by injection molding. If you choose a transparent polymer, like polycarbonate, for example, this is a vehicle's headlamp cover. So this is injection molded as well. Day-to-day equipment, like this little shovel or scoop, or for food industry, this little bowl, if you go like a takeaway, this is also injection molded. Other items, for example, like this safety glass, this is actually plastic, and all these components, they're all individually injection molded as well. So there is a wide range of different things can be made with injection molding. These are just a few examples. Right, so now, if you come here, and let's look at these two equipments. This is the injection molding we're doing with today. Now, if you look at that area, this is another injection molding machine. Now, you may think this one looks almost identical to the other one we're going to use today. You're right, because this one is an injection molding machine for thermoset polymer. Now, the fundamental difference between thermoplastic and thermoset is with thermoplastic, you can apply heat, melt it, mold it. And in theory, you can do this over and over again. In reality, of course, you have degradation. Whereas thermoset, it's almost like a resin. There is a chemical reaction triggered by temperature. So if you use the thermoset equipment, then you are triggering that chemical reaction or cross-linking or curing for the particular material. Now, the material I can show you is this one. Is a phenolic resin. Now, I'll show you this equipment, but we will not use this in today's demonstration because this thing really smells, and it actually carries a very unpleasant smell with it, right? So, but this is a typical thermoset material we're using. So now, if you come a bit closer here, we can come back to this equipment. Now, typical injection molding equipment, it has three main parts. The first part would be this. In this case, it's just a funnel. Now, this is actually a material feeding system. Now, in this case, it just basically be open the lid, put the material in. But if you go to industry, there will be chutes or other feeding system that take the material directly into the injection molding machine. Now here, the important thing is you want your material as dry as possible. Now all polymers, polypropylene, polyester, polyethylene, nylon, they all have certain amount of moisture content. Now that moisture can be a major issue if you don't remove it. This is something we will touch on a bit later. The second component is this bit. This is an injection unit. Now the best way to imagine this is a heated metal syringe. Now instead of liquid, you fill it with molten polymer. So inside there's a screw. That screw is like plunger. It moves back and forth. And each time it loads up some polymer, melt it, and then push it out. And that is the injection. Now the final part, if you go that way, the final third part would be the mold. It's that metal block sitting inside. Now with 4 pins. That is the mold we're talking about. Now that mold closes and opens. Each time when it closes, material will go in, and because the mold is cold, the polymer will solidify inside very rapidly, and then once the mold is open again, the molded piece will be ejected, and that's the end of one molding cycle. All right, so these are the three main components for injection molding. Now if we turn around and have a look at the thermoset injection molding. Now there is a very significant difference because with the thermoset, the material is very sensitive to temperature difference. So in this case, unlike the thermoplastic, the material stays cold, and then it goes into the injection unit. It's still cold or at low temperature. It gets pushed along into the mold, and in this case, the mold is actually heated because this is where the chemical reaction takes place, where the curing or cross-linking or setting takes place. So now, I will just recap the whole thing. So if you think about the injection molding, this one we are using today is a thermoplastic. It is hot molten polymer into a cold mold for solidification. Whereas with a thermoset, it will be cold material into a heated mold where the chemical reaction is triggered. So that is a fundamental difference between thermoset and thermoplastic. Now, coming back to thermoplastic injection molding, I have already loaded the material and we're now ready to go. So the first thing we're going to look at is the temperature setting. Now here is the temperature setting we're looking at. Now polymer has, there are so many different types of polymers, and each of them has a different molding temperature or processing temperature. All right. Now if I change a different polymer, I have to change these numbers. Then how do I know what number to change? Now one thing you can do is to look at the polymer itself. Now this is a bag came from the manufacturer. Now you can see the name of the manufacturer, Anius polyolefins, and the type of the polymer here is polypropylene. Now, what we're using here today is a general purpose injection molded grade polymer. In reality, there are many different grades or many different types. The best way to find the processing temperature would be go into the company and find something called material data sheet. Inside, there should be a very clear indication what is the melting temperature, what is the processing temperature, and all the temperature setting on the machine will be changed accordingly. So this is how you get the fundamental information of the polymer itself. Right, so if we go back to the screen, now we're ready to do the injection molding process. Now, before we do this, let me show you this screen. Now, this is the injection unit and illustration we're talking about. Now, at the moment, you can see there's nothing in there, it's just only a screw sitting there. So what I need to do is, imagine this like a shotgun. I have to load the material. So the first thing is I'm gonna load it, and you will see a little bit of green coming up. And also notice the number that's changing on the top. Now that number 14.11, that is the volume of the material currently sitting in the injection unit. That volume is also known as a volume per shot, S-H-O-T, shot. And that is an acronym people use for injection molding industry, describing the volume of the piece you're making. The reason why we use volume is because different polymers come with different density. And the only thing doesn't change is the size of the mold or the cavity inside the mold. And this is the thing, this is the reason why we use volume to describe everything. Okay, so now the material is loaded. What we're gonna do is do the first step, which is called purging or purge. Now, if I move this safety guard away, you can see here, this little bit, that is the nozzle of the injection unit. So the molten polymer comes out like that, all right? And inside there should be a little opening. Now, give me a second, you stay here. This will help everyone to see the whole thing better. So you can see here is the injection head or the unit. Over there, there's a little opening on the other side. And that's the opening that goes into the mold. All right? Now, another thing I want to talk about is this copper color ring. Now that is called a heating band. Now the heating band is what heats up the barrel or the injection unit. Now, if you come back here, I go back to the temperature setting screen, you can see we have different zones. Now, each zone means there is a heating band. So, if we come back to the unit, that basically means we have one and we actually have more of these heating bands sitting beneath